All right, what I'm going to do right now is do a brief derivation of the max height formula of a projectile. And we're going to start out here just with the situation of what we have. Let's say that we have a projectile launching. Let's say it's a 45-degree angle. In other words, the x and the y components in this case both take up two squares. And it's going to move up, and at some point it's going to launch, and it's going to reach a max height at some point where all of the velocity is in the x direction. So how do we find out what that max height is given just the initial launch speed and theta? Well, the first thing we want to do is draw our components again. We have the x, we have the y, they're equal. And so we have v initial y equals v sine theta. And then we have v initial x equals v cosine theta. Okay, standard operating procedure here, nothing really too amazing going on. Our final condition up here for max height, we know that at this point, the final speed is simply just the x component. There's no y component there in the velocity. So the v final y equals 0. So let's determine what equation will be best for solving this. Well, I'm given v in theta, and I want to find the max height. In other words, I want to find out what is the delta y at that point of max height. And we don't have any times to deal with. We just know that the final y speed is 0 at the top. So we know we looked at our kinematics equations, and the fourth equation that we always talk about is this one, which is v final squared y equals v initial squared y plus 2ay delta y. And in this case, we're going to leave acceleration in terms of a of y. I'm gonna discuss using the term g at the end because it will just change the sign of our final answer. So we know that in this case, the final y velocity is 0. And we know that the v initial y is simply v initial, in this case, sine theta. So if I just go ahead and substitute in some of these numbers, I have 0 equals v initial sine theta squared plus 2ay delta y. In other words, acceleration in the y times delta y. And I want to solve for delta y. That's going to be my max height. And when I distribute this squared property through to the sine and the v initial, and then I subtract that over, I'm going to get negative VO squared sine theta squared, and then I just divide it by 2AY, and I'm going to get this equation here. Now, you may see this written a little bit differently sometimes. They may write it like this. You may see this in textbooks written as this. And so you may see it written as H equals VO squared sine theta squared over 2g. And that's just recognizing that acceleration in the y is negative g. G is just a number. It's a constant, which is assuming that if you're close to the Earth's surface, that the acceleration or the field, the gravitational field, is the strength of that. The magnitude is 9.8 meters per second squared. But it really depends on the direction in which you define your axis. I mean, if you define your axis as down, g will be positive. If you define it up, it will be negative. And when we get into forces, we're going to see that it completely depends upon the direction that you define your positive y-axis. You could define your positive y as down, and g will be positive. You could define it up, and g will be negative. So in this case, typically we would just say that the y component direction is up, and so acceleration in the y is negative g. When you do that, the negative sign drops out here, and so this just becomes positive. So they're exactly the same thing. It's just you're substituting in a symbol, and you will see a similar thing when we get to charges. Coulomb's law for the force of attraction. Sometimes we'll put in for two forces that are charges that are attractive, we'll put in a negative q and a positive q. So we'll show that the negative form of that means they're attractive, and the positive form means that they're repulsive. So that's all that is. It's essentially the same thing, and it's really conditional based upon what you're defining as your positive y direction. But typically when we're working with numbers, not symbols, but numbers, I always like to just say that acceleration y is negative 9.8 meters per second squared. And we just stick with that when we're working with the numbers. But if you're dealing with symbols, sometimes this is more useful. Okay, sometimes this is more useful. So it really depends on what you're trying to accomplish in the problem.